Hello and welcome. In this lesson, we will talk about graphing a line from the intercepts by using the standard form. Recall that to graph the equation of any line, we need at least 2 points. The equation of a line can be given in two main forms: y equals mx plus b, which is also known as the slope y-intercept form, and the standard form ax plus by plus c equals 0. When the equation is given in the slope y-intercept form, we always start off from the y-intercept, and that would be our first point on the line, and then from the y-intercept we apply the slope. And this would lead us to the second point on the graph of the line. We connect the points and we're done. This is something that we've learned in the previous lessons. You can check the videos if you'd like to refresh your memory. Now, when the equation of the line is given in standard form, it is more practical and easier to graph the line by using what we call the x and the y intercepts. So let's get started. Remember that the x-intercept of a line is where the line intersects the x-axis. At this point, the y-coordinate is 0, and that helps us find the x-intercept more easily, algebraically, by substituting x equals 0 into the equation and then solving for x. So here is an example. I brought in the equation of the line 2x minus 3y equals 12. This is a diagonal line, as you can see, and it intersects the x-axis at a point which we call the x-intercept. When you look at the coordinates of this point, the first coordinate, which represents x, is 6. That indicates the x-coordinate on the x-axis where the line is crossing. The y-coordinate is 0, and this will be the case for all the x-intercepts, no matter what kind of function or graph you are drawing. And we use this fact, at y equals 0, to determine the x-intercepts algebraically by simply substituting y by 0 into the equation. Now, the y-intercept of a line is where the line crosses the y-axis. Now, at this point, the x-coordinate will be 0, and that will help us find the y-intercept algebraically by simply substituting x by 0 in the equation and solving for y. So, in this line, we're going to say that we have the y-intercept at this point where the line and the y-intercept cross each other, and we're going to look at the coordinates 0, negative 4, and as you can see in here, the y-coordinate, which is the second coordinate, is negative 4. It indicates where on the y-axis the line intersects at, and the x-coordinate is 0, and this will be the case for any y-intercept. So that will in addition help us to find the y-intercept algebraically by substituting x equal to 0 and then solving for y. So let's practice how to find the x and the y-intercept of this line algebraically, since we already have the graph. So as we said, to determine the x-intercept of the line, I'm going to write the equation of it, 2x minus 3y equals 12. We're going to make y equal to 0. Now remember that when we say 3y, the operation between number 3 and y is multiplication. So read this: 2 times x minus 3 times y, which means times 0 this time because y equals 0, equals 12. So that means that 2x minus 0 equals 12. That's because multiplication by 0 will always give a 0. Simplify some more so that we can solve for x. So 2x equals 12. And now isolate x. X equals 12 over 2, or 6. We call this the x-intercept because it was found by substituting y equal to 0. And as you can see here, our algebraic solution matches the graphical solution. So the x-intercept is 6, and here y was substituted by 0. So to determine the y-intercept of the same line, and I'm going to write the equation of it, 2x minus 3y equals 12. This time we set x equal to 0. Remember again, 2 times x minus 3 times y equals 12, which means 2 times 0 minus 3 times y equals 12. So 2 times 0 equals 0, minus 3y equals 12. And now we solve for y by isolating it. So y equals 12 divided by negative 3, which gives us y equal to negative 4. And since this y-coordinate was found by substituting x equal to 0, we'll say that this is the y-intercept. As you can see here on the graph, the y-intercept of this line is at y equals negative 4, and obviously x equals 0. So let's practice this in a few more examples. If you feel confident that you can do this on your own, just pause the video and try this on your own and check the solution later with me. So example number 1, 3x plus 6y equals 24. Again, this is not in slope y-intercept form, so I'm going to graph it by using the x and the y-intercepts. This is how I like to show my work. So I write x-intercept means that y equals 0. So in the equation, I write 3 times x plus 6 times y now would be 6 times 0 because y equals 0, and then equals 24. So 3x plus 0 equals 24. 3x equals 24, which makes x equal to 24 divided by 3, or x equals 8. So we'll say that the x-intercept of this particular line is 8. So in a similar way, we determine the y-intercept. This time x must be 0, and we rewrite the equation as 3 times x. So x equals 0, so 3 times 0 then, plus 6 times y equals 24. 3 times 0 is 0, plus 6y equals 24, which will make 6y equal to 24. Isolate y, 24 over 6, and we'll say that y equals 4. So the y-intercept of this line is 4. So let's plot the x and the y-intercept. This is how I like to plot the x-intercept or the y-intercept. It's a similar method. So I start from the center of the Cartesian plane, or the origin, so 0. If I am locating the x-intercept, I have to move along the x-axis. Since my x-intercept is 8, that means that I have to move 8 units along the x-axis in the positives, because it's a positive 8. And then I stop here, and I mark the point by a visible dot. And then in the same way, I mark the y-intercept. So from the origin, y-intercept is 4, so it's positive, which means that I'm moving up, and I'm going 1, 2, 3, 4 units up, which marks the y-intercept. Now what I'm going to do is connect the 2 points. As we said before, we only need 2 points, well, the list, to draw the graph of a line. So let me see, I'm going to try to do a good job connecting them. Okay. All right, so let's make this perfect. All right, this is as good as it can be. So this will be the graph that represents this linear equation. And to indicate this, I always label the graph by its equation 3x plus 6y equals 24. And I'm done. So let's continue with one more example. This time we have 3x minus 5y plus 15 equals 0. And as I mentioned before, please feel free to try this on your own first and check the answer with me later. I'm going to start off by finding the x-intercept. I know that y equals 0 there. So 3 times x minus 5 times y changes to 5 times 0 plus 15 equals 0. So the equation is 3x plus 15 equals 0. So I'm solving for x, which means x must be in one side and number 15 must go on the other side. So from positive, the sign of 15 will change to negative. X equals negative 15 divided by 3, which means that x equals negative 5, and that will represent the x-intercept. Now let's find the y-intercept. This time x equals 0. So 3 times x minus 5 times y. Let's make this one 0. So 3 times x, since x equals 0, 3 times 0, minus 5 times y plus 15 equals 0. So 0 minus 5y plus 15 equals 0. Minus 5y equals negative 15. So y equals negative 15 divided by negative 5. So that will give the y-intercept equal to positive 3. So now let's plot both x and y-intercept on the Cartesian plane. So for the x-intercept, I start from the origin, and since the x-intercept is negative, I will have to travel towards the left where all the x less than 0 values are located. So we're going 1, 2, 3, 4, 5. So here would be the x-intercept. For the y-intercept, since it is 3, again from the origin we go 1, 2, 3 up because it's positive, and this will mark the y-intercept. And now let's connect the x with the y-intercept. Okay, and draw arrows on both ends of the line. That indicates that the line can continue, so we only show the part that we can on this math space that we have. And one last thing, never forget, label the line by its equation, 3x minus 5y plus 15 equals 0. Now the whole world knows that this graph or this line represents the equation of this line. So in the next examples, I would like to take graphing the equation of a line from the intercepts a little bit further, and I'm going to change up the example a little bit. So this is a little bit more of a thinking question. So here we go. We have to find the slope of a line when we know what the x-intercept is. So x-intercept is negative 4, and the y-intercept is negative 6. So we are given the information about where the x and y-intercept are. And then we have to find what the slope is. Remember in the previous questions, we had to find the x and the y-intercept. So we are reversing what we are learning. So we are using it in a reverse way. Okay, there are two ways of doing this, algebraically and graphically, and we're going to do both of them. Algebraically speaking, I would interpret the information given a little bit differently. So x-intercept is -4. I'll write that down. And then y-intercept is -6. So I'll write that down as well. Now remember that when we said x-intercept equals -4, in our case, we said that the -4 will represent the x-coordinate at the x-intercept. So the y-coordinate, we said, will always be 0. Similar to this, for the y-intercept, we said that the value of the y-intercept will indicate the y-coordinate at the y-intercept. And remember that we write the y-coordinate second in the ordered pair. Okay? So that's where the -6 will sit in the ordered pair. And then the x-coordinate will always be 0. As you can see here, what we have just done is rewrite the x and the y-intercept as ordered pairs. So this would be our step 1. And I'm going to write it down here. So rewrite the x and y-intercept as ordered pairs. And this is kind of easy to figure out, remembering that for the x-intercept, the other coordinate is 0. For the y-intercept, the other coordinate is 0. So we have y, then x has to be 0. X-intercept, we have x, so the other coordinate, y, is 0. And from here, it becomes a problem very similar to what we have done before. So we are given the coordinates of 2 points, x1, y1, x2, y2. And what we have to do is find the slope. So we're going to say slope equals y2 minus y1 over x2 minus x1. We've already marked y1, y2, x1, x2, so we know their values, so we substitute. So y2 is -6. So -6 minus y1 is 0. So -0 over x2 is 0. So we write 0 minus x1 is -4. Now careful, when we are subtracting a negative, we have to show the subtraction sign separate from the negative sign. Okay, very easy to make a mistake there, but you won't, I know. So we have -6. 0 minus -4 is +4. You see, it makes a difference. So we'll say that slope equals -6 over 4. When you think about it, and I hope you remember, slope must always be written in reduced form. That is considered to be the most simplified form of it. So in this case, what we do is we divide both 6 and 4, -6 and +4, by 2, because that's a common factor. They're both even numbers, right? So now we'll say that the slope, the value of the slope, is -3 over 2. Now we are going to solve the same problem, but this time graphically. And you will see the reason why we want to look at it from both perspectives. Okay, so we're going to start by plotting the x and the y-intercept. And I know that some people like myself like to write the information down before using it. And it's a good habit actually to have when you are solving problems in math, but also in sciences as well. So y-intercept equals -6. So the next thing I want to do is locate where x -4 is. So we're talking about the x-intercept. So from the origin, I go 4 units into the negatives, and that would mark the x-intercept. And for the y-intercept, I go 6 units into the negatives on the y-axis. That would be the y-intercept. And now I will connect, or I will have to find a way of how to go from the x-intercept to y-intercept and vice versa, because that will help me determine the slope. Remember that slope is easy and fun just to remember to rise and then run, which means you go from one point to the other, but remember you have to only move horizontally or vertically. So if I chose to go from the x-intercept to the y-intercept, I would move vertically 6 units down. So I will mark this as -6. And then I will have to move horizontally 4 units to the right. So I will mark this with a +4. So -6 will represent the rise, and +4 will represent the run. So I know that slope is rise over run, so I will substitute rise by -6, run by 4, reduce it, and that will give -3 divided by 2. Now, you probably already noticed that the rise in the slope is actually the y-intercept, and the run is the x-intercept. And if you did recognize this, that is awesome, and you can use it. It is right all the time, so it is true all the time, and you can use this to find the slope when you know the x and the y-intercept more easily this way. Okay, so this is it for this lesson. I hope everything made sense and it helped you understand very well how to draw the graph of a line from using the standard form through x and the y-intercepts. Thank you for watching. Bye for now.